In an electrical circuit, the resistance of a given conductor varies directly as its length, and inversely, as the area of its cross-section. However, the temperature must remain constant for this rule to apply. This rule may be expressed in a formula as follows: R, which is the resistance, equals K, which is the constant, multiplied by L, which is the length, is then divided by S, which is the cross-sectional area. K is a constant, which depends upon the resistivity of the material used. For example, copper has resistivity of 10.4 ohms at 20 degrees Celsius. In the previously mentioned formula, L is the length of the conductor in feet, and S is the cross-sectional area in circular mils. For example, to find the resistance for 400 foot of copper conductors having a cross-sectional area of 100 circular mils, the formula is applied as follows. In step 1, finding resistance, we will use the following formula. R, which is the resistance, equals K, which is the constant, multiplied by L, which is the length, is then divided by S, which is the cross-sectional area. Based on the values, R, which is the resistance, equals 10.4 ohms, which is the constant, multiplied by 400 foot, which is the length, is then divided by 100 circular mils, which is the cross-sectional area. Therefore, the resistance is equal to 41.6 ohms. Notice, the cross-sectional area of a conductor is measured in circular mils, with 1 mil equal to 1/1000th of an inch. 1 circular mil is the area of a circle having a diameter of 1 mil, or 0.001 inch. The area of a square having sides equal to 1 mil is 1 square mil. The illustration shows an exercise problem and the relationship of a circular mil to a bus and conductor. In the exercise problem, what is the resistance of 600-foot copper conductor with a cross-sectional area of 200 circular mils? In step 1, finding known values, L, which is the length, equals 600 feet, K, which is the constant, equals 10.4 ohms, and cm, which is the circular mils, equals 200. In step 2, setting up and applying formula, R, which is the resistance, equals K, which is the constant, multiplied by L, which is the length, then divided by S, which is the circular mils. Based on the formula, R, equals 10.4, multiplied by 600, then divided by 200, which equals 31.2 ohms. Therefore, the resistance is 31.2 ohms. The formula for figuring the area of a circle is as follows. D is the diameter of circle. Notice, di is multiplied by r squared. Ti equals 3.14159. R equals radius of circle. For example, if a circle has a diameter of 1 mil, the area in square mils is 0.7854, which is multiplied by 12, or 0.7854 square mil. Since a circular mil is defined as the area of a circle having a diameter of 1 mil, then 1 circular mil is equal to 0.7854 square mil, and 1 square mil equals 1, divided by 0.7854 circular mil, or 1 square mil equals 1.2732 circular mil. The formula, A, which is the area, equals 0.7854 d squared, gives the area of a circle in square mils when the diameter is in mils. This is based on 1 square mil, which equals 1, divided by 0.7854 circular mil. The area of a circle in circular mils may be given as follows. A, which is the circular mil, equals 0.7854 d squared, divided by 0.7854, which equals d squared. The area of a circle in circular mils can be calculated by merely squaring the diameter. Resistance in electric circuits produces heat, just as mechanical friction produces heat. This is called the heat of resistance. Usually, the heat of resistance is dissipated as fast as it is produced, and the conductor of the circuit may become only slightly heated. However, if the current flowing in the conductor is so great that it generates heat faster than the heat can be dissipated by the surrounding air or insulation, the conductor will eventually overheat. This condition can cause burning and melting of the insulation and create a fire. Consider two conductors having the same resistance, and generating the same amount of heat. Notice, they carry the same amount of current. If one conductor has a greater surface area, it can carry more current without damage, because it can dissipate the heat faster than the other. For example, if one copper conductor has a length of 1 foot and a cross-sectional area of 20 circular mils, and another copper conductor has a length of 2 foot and a cross-sectional area of 40 circular mils, the resistance of the two conductors is the same. However, the larger conductor can carry more current because it can dissipate heat more rapidly. The illustration shows two lengths of conductors having the same current and heat. The larger conductor will carry more current than the smaller one. When testing your skills, refer to the National Electrical Code, select the diameter and inch-to area of a 4-volt, AWG, THHN copper conductor. Based on a 4-volt, AWG, THHN copper conductors, the answer is D, in which the diameter is 0.642, and the inch-to area is 0.3237.